Now we go into what is called the Gibbs phase rule. To understand metamorphic petrology, you have to know Gibbs phase rule. You have to know Gibbs phase rule. Conceptualize Gibbs phase rule. I have already sent you the derivation. I think you have read it. It is essentially calculated Gibbs phase rule, which is famously given by the formula F is equal to C minus P plus 2. This essentially is called the degree of freedom. Degree of freedom, also called variance. Then you have C, which is the system component. And then you have P, which is the number of phases. And 2, stands for pressure and temperature. The variables pressure and temperature. So you have the system number of phases, system components, which is the minimum number of components, and the degree of freedom, which is also called the variance. What is variance? Variance is very easy to understand. Variance is essentially number of variables minus number of equations. That's it. Say, for example, I write an equation 5x plus 2y is equal to 4. 5x plus 2y is equal to 4. Right? What is the variance of it? If there was something called a variance. Number of variables minus number of equations. X is a variable, y is a variable. So, 2 minus 1 is equal to 1. What does this mean? That you have 2 variables and 1 equation. So that means 1 variable will remain undetermined. Or you cannot find out x and y both from 1 equation. You cannot find out. You need, from this 1 equation, you cannot find out unique values of x and y. So the value, what is the problem? If the number of variables are 2, but the number of equations are 1, so you have a difference of 1, that means you need an input data. X and y both cannot be determined. Have you understood? You need an input data of either x or y to determine the other variable. Have I been clear? Either you need a value of x to find y, or you need to have a value of y to find an x. There are 2 ways to do it. One equation will not allow you to quantify both variables. You will be left with one unknown. That is degree of freedom, and that is variance in metamorphic petrology. Essentially, number of variables minus number of equations. That's it. This can be done by 2 ways. Which can be done? We were talking either you need a value of x to find y, or you need a value of y to find x. So I can write, say for example, one case may be, I write x is equal to 2. Right? The value for x is equal to 2. So I have x, so in this expression, I will have 10 plus 2y is equal to 4, which means y is equal to 4 minus 10 divided by 2, that is minus 3. That is the value if x is equal to 2. If x is equal to 2, 10 plus 2y is equal to 4, that means y is equal to 3. What have you done? You have put in a value of x. Have you understood? You have put in a value of x. In metamorphic petrology, the degree of freedom means the system left to itself cannot find both x and y. It can either find, it cannot find x and y. You have to put in one to get the other. Information, quantitative information about the other. That is what is called a metamorphic variable. So this is one way. You assign a value that the system is not assigning. You either assume or you derive it from some other place and put it in there, whatever you do, but you have to do it. Or another way could be, you could write 5x plus 2y is equal to 4 and x plus y is equal to 1. So now what you have? You have now two equations. So it says 2 minus 2 equal to 0. Means what now? Now it says that, okay, with the information you have given, I get it, the system can find numerical values for the variables by itself. For the values, for the equations you have given, the system can find its value. You don't need to bother. You don't need to get some inputs from other. It is built in the system. So for example, how do you do it? So here, for example, y will be equal to 1 minus x. From here, and you put it in this, 5x plus 2 into 1 minus x equal to 4. And so it's 5x plus 2 minus 2x is equal to 4. And so you can see, you can find the value of x. I have told this is A and this is B. Right? What have I done? In the first place, I have given a value x is equal to 2. Given a value x is equal to 2. And here I have added an additional equation. There is no difference. A and B looks different, but in concept it remains the same. Why? Because this is also an equation. X is equal to 2 is also an equation. And here x plus y is equal to 1 is also an equation. This was just only to tell you when we put in a value. When you put in a value means what? Put in a value for a variable, that's an equation. So A and B, although they look different, they're one and the same. Because here you have used an equation, here you have used an equation. Essentially no difference. Essentially no difference. Because you have two equations, your variance is 0 here. And if I had given you this only, 5x plus 2y is equal to 4, the number of equation would have been 1 and your variance would have been 1. That's the important point. That means, when I talk of degree of variance, I'm trying to find out metamorphic variables. I am trying to find out the metamorphic variables that the system number of variables, you see, is not telling me which variable. It is telling me the number of the variables that remains unquantified. That is what variance is. Variance is the number of values, the number of variables that are unquantified in the system. The system by itself cannot generate the values. But it only tells you what is not there. It doesn't tell you how many variables it can find out. It doesn't say. It only tells you how many variables it can't find out. Have you understood? That is the catch of Gibbs phase rule. It does not tell you how many variables you can find out. It can tell you only the number of variables it cannot find out. The number of variables. Not even what is the variable. No. It says the number of variables that that the system cannot determine. So those are the values you have to retrieve from somewhere else or change your system so that your f becomes equal to 0. That means whatever variables you give, it will be determined. But when you have f has a value, it means that that is the number of variables. And it doesn't tell you what is the variable. It tells you the number of variables that it can't find. It is about inability. It is not about ability. Degree of freedom tells the inability of the system to give you a particular variable. That is the important part. I hope I have been able to clarify the position, and this degree of freedom can be found out if you know your system components. Now you know, so there are minerals. I should know the compositions of all minerals to find out system compound. I should know all the phases, all the thermodynamic phases, and that may or may not include fluid phases that I told you before. And only when you do that, and plus 2 tells you how many variables remain unquantified. Tricky, no? Metamorphic petrology is philosophy. It has great philosophy in it. You have to understand it dead accurate. You will have no problem in understanding metamorphic petrology. You have to be dead accurate with your concept. That is why metamorphic petrology in India, for example, if you look at the geoscience fraternity, you will be going into research. Some of you will be going to jobs, okay? So those of you going to jobs, you will maybe not very much interested in other things, higher things. You can do it with whatever you will be trained for and your initial knowledge. But those who will go into research will find out that metamorphic petrologists per se and structural geologists per se who are regularly publishing in such journals at the highest level, that number is very small. It is because of the difficulty of conceptualization. Petrology, we had many metamorphic petrologists in earlier times. Now it has gone down and down and down and remains in only particular places in India. Very small schools which had a very strong history of metamorphic petrology. They have retained a bit, similarly with structural geology. Most people do geochemistry. Yeah. So, I hope we have understood this, right? Now it's time that we look at certain examples and try to make an example more and more complex so that you start finding out the difficulties in how Gibbs phase rule becomes the starting point of metamorphic petrology. Now, before going into Gibbs phase rule, I shall tell you a little bit about variables in metamorphic petrology. There are two types of variables in variables. One is called an intensive variable. Intensive variable. What is intensive variable? Variables that do not depend on the mass. Do not depend on the mass. Say, for example, refractive index, not metamorphic petrology. Refractive index, specific gravity. They don't depend on the mass. Similarly, pressure and temperature, they don't depend on the mass. They don't depend on the mass of the substance. Have you understood? And then, for example, mole fraction. Mole fraction it does not depend. Say, for example, you have a garnet with 20% almandine. That's the mole fraction of Fe in garnet. Now, you can have many garnets having the same composition. So, it does not depend on the mass, but it depends also on the masses of different components in the garnet. That's sure. But you can have, these are called the intensive variables. And what are extensive variables? These are just the opposite. Extensive variables. These are just the opposite. Mu is equal to G by N. Yes, this is called chemical potential and this is called free energy. And G by N, that means molar Gibbs free energy, is called the pure potential per mole. So it does not depend on mass. So chemical potential is an intensive variable, but G is an extensive variable. So is entropy, so is volume, not volume, free energy, enthalpy, say for example, enthalpy. These are all dependent on mass, but these variables are not dependent on mass. Molar volume, this is not dependent on mass, it's an intensive variable. So essentially in metamorphic petrology, what we try to do is try to quantify the variables, and these are, I gave you a write-up on different chapters for you to read, and there they talk about the relationship between pressure, temperature, free energy, enthalpy, entropy, and so on and so forth. So they essentially correlate intensive and extensive variables in it. But let's talk about variables in general. Well, now let's take this phase diagram. Andalusite, sylvinite, and kyanite. And this is called the triple point. This is equal to 505 degrees centigrades and 3.7 kilobar. Now, at crustal depths, 1 kilobar is equal to 3.3 kilometers. That means if you have a column of 3.3 kilometers of the crust, at the base of that 3.3 kilometer column, you get 1 kilobar pressure. So it's essentially H rho G. Height, H, rho, density, and G is the acceleration due to gravity. So 3.3 kilometers into the density into the acceleration due to gravity, and then you get 1 kilobar pressure. So if you are talking of 3.7, then it is 3.3 into 3.7 kilometers. That is the depth. You can see it will be somewhere between 10 and 11 kilobar. So 3.3 into 3.9, yeah, it should be around 11 kilometer depth. So the triple point where kyanite, sillimanite and andalusite coexist, it is roughly at 11 kilobars. You know brittle ductile transition of the crust, brittle at the top, ductile at the bottom, and you have a place where you have brittle ductile transition that occurs between 10 and 15 kilobars within the crust, depending of course on the rock type. But normally felsic rock, it's talking about based on brittle ductile transition, so it's somewhere there. So 3.7 kilobars is roughly around 11 kilometers. So it's the brittle ductile regime of the crust where the three polymorphs are going to form a triple point. Now we talk about Gibbs phase rule. Now, my first question to you, if I ask you, what is the variance of the triple point? And all of you will say, 0. Bullshit. Wrong. Why wrong? You forgot what I asked you to do. 0. No. Wrong. Calm and quiet. What you should ask the first question. You understand the triple point here means kyanite, sillimanite and andalusite are the three phases. So I understand P is equal to 3. 3 phases up there. P is equal to 3. That I understand. But the moment I want to compute C, I have a question. I have to find out the system components. Minimum number of system components. And if I have to find it out, then the first thing that comes to my mind, what is the formula of your simple note? If you say Al2SiO5, that's for the pure, remember. If your teacher has that in mind, let him say it out. Let him spit it out. If the teacher tells you what is the triple point of the Al2SiO5 phase diagram, he's right. He's right. You see, I will tell you again. If your teacher asks you, what is the variance at the triple point of the Al2SiO5 phase diagram, means what? He has told you that all the phases, sillimanite, kyanite and andalusite, they have the composition Al2SiO5 and nothing else. Have you understood? Mark my question. What is the variance of the triple point of the Al2SiO5 phase diagram? I told you that C is Al2SiO5. C is 1. He has told you this. But if he says, what is the variance of the triple point where sillimanite, kyanite and andalusite coexist? See, something is missing. Find out the variance of the triple point where kyanite, sillimanite and andalusite coexist. He has not given you a crucial information for you. He has not let out the composition. His question is wrong. But if he said, as I said earlier, what is the variant of the triple point in the Al2SiO5 phase diagram, you can, of course, ask him what are the phases, but then it means you should go back to KG1. But at this point, for a first year student, he would not know. Really, he would not know because he has not been told. Yes, correct? So there are two questions. What is the variance of the triple point where kyanite, sillimanite and andalusite coexist? Is one question. And the other question is, what is the variance of the triple point in the L2SiO5 phase diagram? Same question. But in the first question, he does not specify L2SiO5. He does not let out the composition. So that is why, when I ask you, what is the variance of the triple point where sillimanite and a lucite kyanite is there? The first thing that you should ask yourself, or the teacher, what is the composition of sillimanite, kyanite and andesite? What is the composition? Because without the composition, you will not be able to find out C. You will not be able to find out just the components, that is C. Impossible, you will not be able to find out. Okay? Okay, what I will do is, I think we will stop here because I think the next, I don't want to have a break. So we'll stop it and the next you see in my fourth video.